It is now 2 p.m. East African time. Welcome to our webinar, the sixth webinar under the webinar stream of transboundary wetland management. Kindly, if you're joining us now, please introduce yourself under the chat, state your name, affiliation or organization, and the country you're joining us from. Today's webinar is under the title, Understanding the Status and Hydrology of Wetlands in the Nile Basin. And as I said, we have lined up some of the best experts in this field, working practically in the field, working practically in the Nile Basin region, and they will share the work that we have been doing under the Nile Basin banner on these issues of hydrology and wetlands in the Nile Basin. So welcome. I will be your host, Leonard Akwan. I will be helped by my colleague, Carlos Sanchez from PIZ. And of course, we are convening this webinar in partnership with the government of Uganda, specifically Ministry of Water and Environment. This webinar will take exactly 1.5 hours, and we will receive opening remarks from our Executive Director of Nile Basin Initiative, Professor Saif, who will give us an introductory remarks and welcome us to this webinar. And then, of course, I will provide an overview of Nile Basin Wetlands Program, the good work we are doing on wetlands in the Nile Basin. And then our first presenter will be Dr. Joe Peterson, who will share on the Nile Basin Wetland Status Report and the inventory. And then we will have Dr. Jens Kiesel, also from Hydroc, who will present on wetlands modeling in the Nile Basin. And then we will have a presentation from Dr. Johannes, who will present on wetlands development options in the Nile Basin and how this is integrated into the Nile Basin Initiative Decision Support System. And then, of course, we will have a round of discussions with the speakers on these issues, and then finally have a wrap-up and key messages from my colleague, Mr. Sadiki Leiza. So please feel welcome, and without much ado, I will invite our Executive Director, Professor Saif, to give his opening remarks and introduction to this webinar. Welcome, Professor.
Just to make sure that I'm not... Okay, thank you, Leonard. Dear experts and participants, good afternoon and welcome to the final session on wetlands. For the sake of time, I will provide brief introductory remarks for the occasion. We all know that hydrology of the river Nile does not work in isolation. It is impacted by land use changes, overall river ecosystems status integrity, and changes and overall river ecosystem status integrity. The Nile Basin over the years is experiencing land use change, fragmentation, deforestation, and overall degradation. Our wetlands, forests, savannas not spared. These land use changes and degradation is driven by population increase, urbanization, and climate change, and manifested by convergence into agriculture, settlements, etc. Therefore, studies undertaken by stakeholders like NBI study on wetlands inventory, mapping, modeling, and options development provides useful information to inform action such as landscape restoration, land use changes, information like the ones to be shared in this webinar also provides information for the stakeholders, discussions, and development of options critical for river basin planning. So, welcome to this webinar. Let us have fruitful presentations and discussions, and let us work together to incorporate these findings in our decision-making river basin agenda. Thank you, and best and fruitful discussion.
Thank you so much, Nile Basin Executive Director, Professor Saif, for those welcoming remarks. And true, as you have said, information is very key in the river basin planning. And some of the information that has been generated in this work of wetlands will be very key in informing that river basin planning. So I will go ahead and briefly share the overview of wetlands program. Okay, welcome to this presentation. It is on the overview of the Nile Basin Wetlands program. And I will wish to state that wetlands cover about 5% of the Nile Basin.
Fasting, but how? Today, I'm not fasting, yes.
And that therefore wetlands offer ecosystem services that are very critical for the socioeconomic development and overall environmental sustainability of the Nile Basin. And that our work in the Nile Basin focuses on transboundary wetlands and wetlands of regional significance. These are wetlands which are shared between 2 or more countries, or wetlands which exist in one country but are very relevant for the hydrology and for the livelihoods of the Nile Basin. And therefore, there is need for these wetlands and wetlands-related ecosystems because of their value and their benefits to human beings and to the economies to be mainstreamed in the river basin planning at the Nile Basin level, that is the wider basin level, but more practically at the sub-basins level. So our work within the Nile Basin has been geared towards best practices. And over the years, the Nile Basin has developed an inventory, the first one in 2009. They have wetland management strategy to direct the work we are doing. And of course, also the environmental and social policy framework, which provides a lot of emphasis on the natural assets, on sustaining the natural assets of the River Nile. And then, of course, there is an NBI climate change strategy. This strategy is based on ecosystem-based adaptation, which taps so much on wetlands and wetlands-related ecosystems. And then, of course, there is the Nile Basin Environmental Flow Strategy, which has been developed, and this is geared towards ensuring that there is water. In the water allocation planning, there is water for the Nile Basin, for the aquatic ecosystems. Then, of course, there is the Nile Basin Water Resources Atlas, which maps some of these freshwater resources, and so that it can inform planning. But of course, within this study, we have also developed the Nile Basin Wetland Atlas. And then, of course, the environmental sustainability pillar, which advocates for ensuring that whatever we do in the Nile Basin, sustainability is part and parcel of it. And therefore, over the years, we have come up with practical actions in developing transboundary wetlands management plan, and of course, mainstreaming wetlands in the infrastructure, water infrastructure that we develop. We ensure that wetlands are part and parcel of those infrastructure. Currently, the Nile Basin, and with the support of the German government, have been implementing a project on biodiversity conservation and sustainable utilization of ecosystem services of transboundary wetlands in the Nile Basin. And that within this program, we have done a lot of activities, of intervention, one of which is building the knowledge base. And within the knowledge base, we have got many strategic major studies. And these studies, some of which will be shared in this presentation, are the inventory, developing atlas, and of course, developing monitoring toolkit, the indicators that we can monitor within the state of the basin reporting to capture what is happening, the status and the trends of our wetlands. Modeling, bringing in the relationship between ecology and hydrology. For action, of course, also ecosystem and biodiversity assessment. And we have also undertaken environmental flow study, which we shared in earlier webinars. And then, of course, there is the Nile Basin Wetlands Management Framework Plan, which will provide a framework and to which we can cooperate towards management of these wetlands. And then, of course, SUD study, SUD wetland studies. SUD is a very important, one of the biggest papyrus wetlands in the region, and therefore it is very, very important that we have dedicated studies for SUD. And then, of course, closely linked to that, there is Machar Marshes ecohydrology study. Machar Marshes is in Sudan, South Sudan, and of course also connected from Gambela region in Ethiopia. And then, of course, we have also done carbon study, which we shared in the previous webinar, and of course, economic valuation studies, which we shared in the yesterday's webinar, and then environmental flow study, which we have also shared. And then, of course, in the first webinar, we have also undertaken transboundary wetlands planning, Kagera, Semliki, and this was the focus of the first webinar. And of course, over the years, within our wetlands program, we have created wetlands engagement platforms, be it regional wetlands working group that has got state parties representatives from the Ministry of Environment, from the Ministry of Wetlands within the Nile Basin countries, so that we meet, we discuss, and we push the agenda of the wetlands. And we have also had the Nile Basin Wetlands Forum, two of them, which have also brought in state and non-state actors, sharing on issues of wetlands, coordinating our efforts towards sustainability of wetlands in the region. And of course, lastly, this work then contributes to many areas, whether it is bringing in basin-wide intervention and collaboration among stakeholders in that regard. And also, these countries that we work with have got national and regional obligations. So our wetlands work help them to meet those national and regional obligations with regards to wetlands and biodiversity. And of course, also our countries, our state parties have got international obligations, specifically under the Ramsar and under the Convention on Biological Diversity. So our work helps them to meet those obligations. And then, of course, also obligations with regard to climate change, because our work focuses on ecosystem-based adaptation. So in a nutshell, this is the work that we have done under the Nile Basin Initiative Wetlands program. So thank you. And without wasting time, I will now call upon Dr. Jens Kiesel to present his presentation, because our second presenter, who is Dr. Job, is having a problem with the logging on. We will sort that, but in the meantime, for purposes of time, I humbly welcome Jens to give his presentation on wetlands modeling in the Nile Basin. Please, Jens, the floor is yours, and feel free to share your screen.
Yeah, thank you very much, Leonard, for the kind introduction. So yes, let me share my screen and the presentation on wetlands modeling in the Nile Basin. So this is a joint work that we have done under our assignment. So the group of wetland modelers is myself, Juan Fernandez, and Georg Petersen. And I would like to start with a brief background information. So the wetlands of transboundary significance were currently not sufficiently implemented in the Nile DSS. There were some missing processes, some wetlands were missing overall, and yes, the Nile DSS wetland processes were in that initial phase not coupled to ecosystem services. So, and these facts basically restricted scenario analysis and possible impact studies on climate change or development options, impacts on wetlands. So the task was to improve and implement wetland models in the Nile DSS. So the Nile DSS wetland models should therefore provide an input for ecological assessments and ecosystem services. And basically, the models in the DSS are a translation of inflows, precipitation, and evapotranspiration into wetland area and inundation depth. So basically, the Nile DSS hydrology provides inflows, precipitation, evapotranspiration, also from scenarios, and then the implemented models are able to provide these wetland characteristics. For the Sud and the Mashar marshes, because of their importance and size, we implemented spatially distributed hydraulics. So for that task, we started first with a definition of the wetland status and actions as they are currently implemented. So there are wetlands sufficiently depicted in the Nile DSS. For those, no action was needed. Then there were some wetlands with implausible water balance in the Nile DSS, which should be corrected. The wetlands models in the DSS require certain curves that describe the relationship between water level, depth, area, and volume. And some of these models had implausible data. So that was also required to be corrected. Then wetlands at lake shores were not available, which we need to implement. And then some wetlands of significance were missing in the DSS. And as already mentioned, the focus wetlands of the Sud and the Mashar marshes also needed to be looked at and implemented. So we structured all the available wetlands in the DSS and the ones that were missing in that table. I don't want you to look through or to understand the table in detail, but what is important here is that we derived action plans for each of the wetlands. And as you can see here in the summary, we had one wetland which is sufficiently depicted, 11 wetlands required improvements in the water balance, and 9 wetlands were newly implemented. So let me briefly step through these 3 main groups of wetland in the following slides. So wetland sufficiently depicted, you can see an example here, or the only one that was that passed that mark was the Bahr el Ghazal swamps. So the action was that we could directly use the existing data and link this to ecological assessments. So basically what we need is a curve that describes the wetland water level to the area and volume. So the area of inundation and the volume in the wetland, the water volume in the wetland. Then characteristic levels, so at which, what are the basic geometries of that wetland, and then losses and gains. So how are the precipitation patterns and the evapotranspiration patterns so that the water balance can be calculated correctly. And lastly, the spill curve, which describes the outflow of the wetland based on the water level in the wetland. And with this information here, which is required for each wetland in the Nile DSS, we can then calculate all the required processes. So let me give you an example here for wetlands that had an implausible water balance. so the Barra, Kobo Sobat, Ihema, Rushwa, Nalubale, and Lake Kyoga, had missing precipitation and potential evapotranspiration, as you can see here. So that is relatively easy to fix. For these wetlands, only the respective precipitation and potential evapotranspiration time series have to be linked. Then the lake wetlands. So we have wetlands, fringe wetlands around the lake shores, indicated here in green for different water levels. And these wetlands were not available in the DSS, so we used a relatively straightforward GIS-based assessment of topography. So we derived the inundation area for different water levels in the lake, and then assessed which parts, which areas around the lake shores are inundated. Based on that, we could then derive these water level volume area curves. So as you can see here, for Lake Albert, Lake Kyoga, Lake Victoria, Lake Tana, we then have the area and the inundation of the wetlands for different lake water levels. So for Lake Victoria, we have the highest area, the highest volume of these wetlands, being the largest lake, of course. So now when the lake water level is changing, we can then obtain these different volumes and areas of the wetlands, of the water in the wetland. A bigger problem basically is when the storage elevation curves are implausible. So for the case here of the Nia Barongo, we had a very, very low water level or a very low area for different water depth in the wetland. So what we did here is to use two-dimensional hydraulic modeling, so to simulate the wetland in Hegras to derive the storage curve and also the spill curve. And I will go into further detail with this in a few slides. But secondly, we used the same approach for missing wetlands. So for instance, the Dinda, the Maro, the Mara, the Sio and Zoya Yala wetlands were not available in the Nile DSS. So we were also deriving these storage and spill curves with 2D hydraulic modeling using Hegras. Now the steps there, very briefly, are that we used the Merit DEM to depict the terrain. We used upstream boundary conditions from the Nile DSS, so basically the full range of possible inflows that drive the Hegras model, and downstream boundary conditions are either a range of constant water levels in case wetlands discharge into lakes, or normal depth. That means that the downstream water level is calculated on the bed slope of the river. Roughness values are important for hydraulic modeling, so those were derived from remote sensing, wetland vegetation classification. And finally, to assess the plausibility of the results, we compared those inundation, hydraulic modeled inundation with remote sensing derived wetland extent. An example here for the Mara wetland, where you can see the remote sensing derived extent in a pink outline. And you can see that the derived extent from Hegras matches relatively well, or very well, basically. We have some overestimation here in the upper part. Now, for different water levels calculated by Hegras, we can then calculate the volume and the area, the volume of water and the area it inundates. Also, based on the inflow and the outflows, we can then get the spill curve. So at which water level we have which outflow in the wetland. For the major wetlands, we used a more detailed approach. So coupled 1D, 2D hydraulics for the Masha marshes and the Sud. And we chose the Mike 11 and Mike Xi hydrologic and hydraulic modeling. I would try again in my last presentation. This didn't work, but I would like to show you again, try and show you again the video of the actual simulations and the results of the processes in the wetlands. So when we see here the Masha marshes at the beginning of the simulation, so we are in the dry season, so the water, the remaining water evaporates. Then the rains set in, and we see a first, inundation, large-scale inundation across the Masha marshes. And then at the onset of the wet season, we see the inflows coming from the Ethiopian escarpments, and also here the spillages from the Baro. Now, we certainly see that the wetland processes are both driven by inflows as well as to a large extent by evapotranspiration. As the wet season recedes, we then see here that we have very low water inundation during the dry season, making the Masha marshes a really seasonal wetland. Okay, for the Sud, here we also are now at the onset of the dry, the start of the dry season, where we see the inundation coming from the inflows at Mongala. When the rains set in during the wet season, we have widespread flooding across the whole domain, and inundation reaching almost the full model domain in the wet season. Now, during the dry season, again, evapotranspiration is taking over and reducing the volumes and also the inundation extent in the Sud. So these two videos highlight the importance of linking both precipitation and inflows, and the results that we were able to obtain are plausible. They can explain the inundation as well as the dynamics quite well. Okay, so yeah, this is basically a summary of the two wetting and drying processes that I have just shown. And now the next task is to integrate the results of these models into the Nile DSS. In the Nile DSS, the water volumes are provided by the hydrologic processes, and then we need to update the wetland implementation in the Nile DSS with the derived storage elevation and spill curves. Now, within the DSS, these results can be fed into wetland vegetation model, e-flows assessment, ecosystem services assessment, and downstream flow dependencies. And all this then enables scenario analysis within the Nile DSS. There are some further recommendations for further work and also for using the models. First and foremost, the model results are subject to uncertainties. So we have missing flow data at the inflows and outflows of the wetlands where we struggled with. There are uncertain wetland properties such as elevation, groundwater processes, but also peatland depth is an issue which affects the hydrologic processes. As you are aware now, in some of the wetlands, we were not able to carry out a detailed and spatially distributed simulation within this project. So we have subsurface hydraulic processes in most wetlands depicted in that simplified manner. So possible users must be trained in what is possible with the models, to which extent. Nevertheless, the models can be used as a pre-screening tool. So for instance, if detailed planning or if certain scenarios, development options are implemented, we can see the tendency, what is going to occur, what is going to happen in the wetlands. Nevertheless, for detailed planning and implementation of development options in certain wetlands, this requires still a detailed impact assessment for the respective wetland. So with that, I'd like to close my presentation and thank you once again for the chance to present our work here within the scope of the NBDF. And thank you.
Thank you so much, Dr. Jens, for your presentation on Machar Marshes. Look, Machar Marshes and other wetlands, looking at all those dynamics, and then of course, hopefully, those dynamics will find themselves in decision making. I now take this opportunity to welcome you all as you keep trickling in. Kindly post your questions under Q&A. And if questions and answer option is not active, just post your questions under the chat. And our resourceful people will try to answer all your questions. But again, we will have discussions led by Lucy Iango from the Ministry of Environment and Water. During those discussions, we will be able to answer some of those questions which we have not been able to answer under the Q&A. So please let your questions come in. Please also introduce yourselves, your name, your affiliation or your organization and your country under the chat so that we know who is joining us in this wonderful webinar. Now, let me take this opportunity now to welcome Dr. Jock Peterson for his presentation on Wetlands Inventory and the status. Please, Jock.
All right, thank you very much, Leonard. So let me quickly share my screen. All right. So this presentation is on the Nile Basin wetlands, the status report on the work we are doing. It is quite a significant work package where under the project of Nile Basin wetlands of transboundary significance, inventory, baseline study, framework management plan, and a nested case study in the suit, we are doing quite a range of activities. This includes wetland mapping, inventory, and atlas development, the development of wetland hydraulic models that Jens has just presented, wetland ecosystem services assessments, wetland biodiversity assessments, wetland e-flow assessments, wetland management policies and practices, and framework management planning. Plus, while we are doing all this in the framework of the entire Nile Basin, we run a specific nested case study for the suit, where we go into more detail for the suit. Basically with the overall goal to generate knowledge and understand the physical baseline conditions so that this is going to be the base for educated decision-making and planning. Here in a bit more details on where we are standing. As mentioned, the activities are very, very broad. We have done our technical reporting with regards to the methodologies used. The inventory and atlas are completed. They've been shared for comments and we've included comments. We've reported on wetland monitoring guidance. We've developed a geospatial inventory database, the modeling that we have done that Jens has just described. Quite a range of activities that over the last month and years actually have been conducted, with still basically a few aspects, downstream aspects outstanding, specifically on specifically on the policy aspects and the scenario planning, as well as on the wetland framework management planning. Also, still work in progress is the work on the suit. There, for example, we've gone more in detail with regards to actually applying the wetland-specific environmental impact assessment. This is now in its last steps, and yeah, we are actually expecting any day now that we finalize. Yeah, same for the wetland or suit-specific modeling that we have done. This is submitted and is currently being implemented in the Nile DSS. So we are more or less on the finishing line with all the activities. Most of the aspects that we've been worked on have been combined in a very comprehensive manner. So one work package has been feeding into the next one. And all this data and information is basically available in the inventory, in the related database to the inventory, which will become part of the Nile Basin knowledge database. And it is also integrated into the Nile DSS, where it basically forms part of the calculations and where scenario runs can be carried out. To run you through roughly the activities that we've done on wetland mapping side, yeah, our task was to produce a high resolution and high accuracy land cover classification for the entire Nile Basin, which goes beyond of what has already been done in 2009 in a similar study, let's say, focusing purely on wetland mapping. We have gone into further detail with regards to the spatial resolution that we have used, and also the differentiation of different wetland vegetation classes. So we have, for example, differentiated into water, papyrus, reeds, grasses, forest areas, but also then on the other side, agriculture, desert soils, settlements, and so on. So we have quite a number of more classes as compared to previously, where only simple vegetation has been mapped. As an example for the detail that we can go in, so here this would be for the entire Nile Basin, simply showing wetlands. Here we have a zoom into the Sud region of South Sudan. We can already see here that different vegetation classes have been mapped. And if we zoom in further here, this is a small area here where we can clearly see the lagoons, where we can clearly see the channels running through the swamp system. And we can also clearly see differentiation between reeds and papyrus areas, and here the wetland grasses on the sides, on the seasonally flooded floodplains. For the inventory, we have basically looked into what is available already. So we have gone through a variety of papers, studies, and reports that have previously been done, collected and cataloged all this information, sieved through it, yeah, basically combining all we could find into a database that we have developed in a very structured manner. So it's the different wetlands we have in the Nile Basin are numbered. And then they have indications regarding the sub-basin. They belong to the wetland name, the wetland group, the country, the river, lake it's related to, their latitude and longitudes, altitude, area, nearest town. So all sorts of features to identify them, as well as then the physical features with regards to soil, climate, hydrology, water quality, biodiversity, and so on. So quite a number of parameters that we have included here. As we are dealing with existing information that we have to some extent enhanced by the studies we've done, but to a large extent this is based on the wealth of studies that has previously been done in the system. This, of course, means that for different wetlands, we have a different level of detail that we could achieve. So we have some wetlands, for example, that are very well studied, while we have others that are hardly studied, which basically depends on accessibility, on the economic interest, and so on. So you will, when you access this data, which we of course encourage you to do, you will find that there are differences in the level of detail. But yeah, our task was to give as much as possible information based on available data sets. The third part of work in work package 1 is the Wetland Atlas. So here we have produced a high quality, more high level document that in detail goes into the different wetland groups that we have split into subbasins. So for example, here, chapter 2, Lake Victoria subbasin, chapter 3, the Victoria Nile, chapter 4 would be Sut, and so on. So it goes along the different reaches of the Nile down to the delta. Within these chapters, we have like a similar structure always. We have an overview, introduction, the subbasin characteristics described, including their climate and hydrology, and then a description of the different wetland sites in the subbasin with regards to wetland characteristics, population, ecosystem services, and so on. So based on that, we have then selected focus topics that are of very much interest for specific wetlands in the subbasin. So out of that, we have created these potential and hotspots chapter that highlights certain aspects that in the different wetlands are of importance. And we have another chapter, management status and conclusion. So we have a really comprehensive piece of information here where the individual wetlands are described and the subbasins are described. The issues are really brought out and all that basically on a few pages, so that it's really well digestible with good photos included. So it's something, if somebody wants a very short and pragmatic approach for getting a glimpse of information of what's important and what are the factors in a specific wetland, then this is the first possibility to get this in a short time. We've then come into, we've then done the wetland modeling. Jens has described this in more detail, so I'm not going to tell much about it. We have basically created models for selected wetlands in the Nile Basin that are also included in the Nile DSS. And out of that created the features of what happens in these wetlands under different flow conditions. So if we have a certain inflow into the system, if you have certain rainfall parameters, if you have certain climate aspects, what is the flow in the system, what are the water depth, what is the extent of the flooded areas. This has gone into the Nile DSS, so that now with this embedded in the Nile DSS, when the Nile DSS is being run with different scenarios, for example, with climate change scenario, with a water extraction scenario, with a dam scenario, then the DSS would calculate the effect of these changes in flow onto the wetlands further downstream, and with this indicate what will be the changes in the wetland area, in the flooding depth, and so on. And Jens has already explained that this has already an impact onto the biodiversity, because as a first step, plants are of course affected by that. So we may see a change in wetland vegetation, which again in return as a cause consequence chain leads to changes in the in other species, and with that into ecosystem services that are available in the wetland, and with that also has an impact on livelihood for the local population. An important aspect also contributing to that was the ecosystem services assessment that we have done. So we have looked into what are the different aspects that the ecosystems provide. So there are supporting aspects, there are provisioning aspects, there are regulating aspects, and cultural aspects. These are the most important groups. The supporting services are the nutrient cycling, the soil formation, primary production of different species, not only of the vegetation, but also of fish, for example. With that, we have then the provisioning services. These are food, fresh water, wood and fiber, fuel wood, and so on. We have the regulating services with climate regulation, flood regulation, disease regulation, water purification, and the cultural aspects from aesthetics, spiritual, recreational aspects. This goes into the next level of what constitutes well-being. This could be security, this could be basic materials for good life, could be health, could be good social relations. So basically this all comes down, boils down to livelihoods at the end, and how the riparian populations along the basin, but also in a secondary way, people in the entire basin are leading their lives, and what kind of ecosystem services and with that livelihoods are available to them. The next step, or well, it was conducted in parallel, was a biodiversity assessment. Here we have looked into detail of what kind of species do we have in the different wetland areas. So here, just as an example, the Bar Ghazal, Barokobo Sobat wetlands, Dinner, Kagera, Nile Delta, Semliki. So basically all the wetlands we've looked into. We've looked into different aspects, for example, what kind of species are in there overall, which of them are endangered, threatened, vulnerable, which are flagship species, keystone species. So to understand what are the importances, not only from a ecosystem services and livelihood perspective, so food, so to say, but also what are the relations of the different species, of the different biodiversity groups in between each other, and how they relate with each other and how they react to each other. That's where we then get back to the link with the hydrology, for example, that as an example, if we have a reduced inflow into a system, into a wetland system, we may have changes in area that gets flooded or gets less flooded or gets flooded to a lower level. That again has an impact on the vegetation. That means the vegetation, which is more competitive under certain condition, will take over, and with that the wetlands are changing. So that means grasses may take over from reeds, reeds may take over from papyrus, and with that, of course, we go further down the line. That means we may have a change in fish production, we may have a change in grazing grounds, and so on. Another important cornerstone of our study was the environmental flow assessment. Gordon, in previous sessions of the NBDF, has already reported on that in detail. In here, we've basically looked into how can we connect the different flows into the system with the impact it has on the biodiversity, and where are the thresholds of flow that lead to a certain status of the wetland with regards to wetland health, and in that also with regards to the ability of the wetlands to provide their ecosystem services and with that livelihoods. We have developed a methodology specifically for wetlands. The wetland systems, they are not linear systems, not purely linear systems like we have in river systems. but we have the seasonal flooded areas. We also have the permanently flooded areas. So over the season, we have quite some changes and significantly higher changes as we would have in a pure river system. And this has been considered in the wetland e-flows methodology that we have developed. So this is now specifically for wetlands and has been applied as an example for the suit as part of work package 8, where we have looked into the suit into more detail. As mentioned, there is another presentation available from Gordon, who has gone into much detail there. So I recommend, if you're interested in that, please have a look into that presentation. Right. Our work package 6 was then management policies. Here we have looked, well, first of all, we've done an inventory of what is happening in the different Nile Basin countries with regards to our management of the wetlands. What is the status with regards to policies and legal document available, with regards to their implementation status, with regards to their enforcement status. We've also looked into what is the actual knowledge that is being used from the hydrology side, from the biodiversity and ecosystem services side. So how does this all play together? What is the status in the different countries in that regard? What is being used where? And we've come up with recommendations then on what are the proposed steps for an educated management of the wetland systems in order to ensure that their benefits are fully maintained and utilized for the good of the local population. And we've also worked on a framework management plan for wetlands. Here, basically, this is a plan that builds onto the policy work that we have done, where we have looked into what is already available with regards to the management of wetlands. It has been structured in a way that we look into an introduction, so a status quo, what is the current situation with regards to the health and the ability of the wetlands to provide ecosystem services, what's the status quo, what is the required effort to work with the system, and the need for framework management planning. Then part 1, we've looked into the wetlands of transboundary significance with regards to biodiversity status, guiding principles, vision, purpose, and scope, because that should lead into which direction in the future the wetlands are being developed, how they're being utilized, how they're being protected. When this aspect of protection comes up, we always need to keep in mind that the protection of the wetlands is not intended to be simply to maintain their beauty and to maintain the environment, but it is maintained so that these wetlands can provide their ecosystem services. And these ecosystem services are, of course, very, very important for providing livelihoods to a huge amount of the riparian population. So this is what we are keeping in mind. We've then looked into strategic action areas, cross-border wetland management, climate change action, wetlands and basin planning, wetlands of regional significance, the monitoring, which is very important to understand how wetlands are developing over time, and in order to be able to make educated decisions, knowledge management, wetland investments of what can be planned there. And from there, then we go the next step into the implementation arrangements with regards to governance, financial aspects, monitoring, and the whole chain of execution. So we give recommendations in that regard. This framework management plan is currently still under development, so there are still some changes, and there will also be the chance for review. We are then coming to the suit case study. So as mentioned before, This work package builds on the previous work step that we have done. Is basically a reflection of all the topics covered in more detail to provide a case study. So it includes the detailed modeling that Jens has presented in previous sessions. It includes a detailed e-flow assessment. It includes also more on-ground activities together with the stakeholders, specifically with regards to data generation, knowledge generation, and the wetland management planning support that we are providing. This work package is also still ongoing at the moment, as with travel restrictions in place with the pandemic situation, things are not as easy as previously envisaged. So this is still ongoing, the results for this will be available during the course of the next month now. So thank you very much. This was a rough overview of the activities that we have done in this project. Any questions? Welcome. Thank you very much.
Thank you so much, Jock, for your presentation on the wetland status report and also the inventory and the work that you have done. And of course, it's very great to see the results which are coming out, and these results will finally inform. Now we are moving to the next presentation by Dr. Johannes. Please, Johannes, the air or the floor is yours.
Thank you very much, Leonard. If I could quickly share my screen. Are you able to see my screen?
Yes, we can see it very clear.
Thank you very much, Leonard. Again, I would also like to extend my welcome to all the participants. I'll be talking about wetland and development options in the Nile Basin under the context of the strategic water resource analysis. Some of the points have been touched upon by previous presenters, so I would try and keep it brief. So the idea is establishing this relationship between water resource and wetland modeling or wetland ecosystem modeling. Basically, it's the application of some of the wide range of outputs produced from the different work package described by Leonard into the water resource planning of the Nile Basin for decision-making through what is called the strategic water resource analysis study. To give you some background and context, as you know, there is an existing as well as perceived challenge in future imbalance of water supply and demand in different parts of the world, and even more so in the Nile Basin, which is basically driven by population growth, industrialization, and economic growth, together with the need to achieve sustainable development and add resilience to the system. Therefore, one of the key questions was on how to meet this growing demand for water and food and energy upstream and downstream sustainably in the Nile Basin. So that's how the strategic water resource analysis was born. It is a comprehensive water resource analysis study launched in 2015, and the first phase was completed by 2016, and the second phase was again launched by the end of 2016. So the objective of that strategic water resource analysis was in order to come up with strategic development options and measures to meet the growing demand of the water resource in the Nile Basin sustainably, and of course to reduce the mounting stress that is expected in the future, and to pass this information upon to the riparian countries so that they could incorporate that into their development plans. So this shows the schematic of the strategic water resource analysis. There are different components fitting into it. However, the core component of the strategic analysis to identify plausible trajectories of water resource components, demand and supply, combination of that, and identify a few scenarios that are both sustainable as well as at the same time able to address the expected gap in water resource in the future. As you can see here, there are different components feeding into the system, both from supply side, from demand side, as well as from the management aspect of it. So the approach is a scenario analysis, which means identifying a set of development trajectories and simulating this future and looking at the different trade-offs and assessing the water demand and supply, and try and see if the future expected gap in demand between demand and supply is well addressed. So we have a comprehensive water resource model and under the framework of Nile Basin decision support system that's able to simulate the different interventions that will be expected in the future. So we have these components are in generally from future projections of demands as well as different management interventions. We can categorize them into four. One is the demand side management, which refers to the different actions the countries could embark upon to achieve efficient water use through reducing the amount of water consumed, of course, without significantly affecting the management objective. The second group refers to bringing more water into the system. These are such as water saving options, desalinations, and reuses, etc. The other group refers to system-wide optimization of water resource infrastructures. In these, we look at optimal operations of dams, alternative coordinated operation between the different water resource infrastructures. And the fourth group refers to managing of flow requirements, which refers to the environmental flow requirement and wetland ecosystem modeling, as you can see here in this component. So this presentation is how this is incorporated into that whole integrated assessment of water resource in the future in order to devise strategic action. So when we talk about wetland modeling or environmental flow and wetland ecosystem services, we can look at them from two dimensions. One is looking at them in terms of constraint, which will allow us to identify the boundary or the extent of the future development option in order to maintain a specific ecosystem health, which is for a given state of ecosystem or wetland integrity. What is the extent of upstream development, or how far can we develop upstream without compromising that desired level of ecosystem service or wetland state. The second way of looking at it is from trade-off or from economic benefit, in order to assess the different trade-offs that might occur as a result of upstream development and change in ecosystem services. This basically will allow us to answer the question, what are the changes or the impacts of those upstream development on the ecosystem services that we are getting from the different wetlands in the Nile Basin. So whether you look at them both from constraint or from trade-off aspects, the question is, how do we really assess and translate a particular scenario or arrangement of development, future development, into the impact on the wetland, and therefore the impact on the ecosystem services that this wetland gives us. So this is basically translating the pressure on the wetlands into change in ecosystem services. So in order to be able to do that, I think the first step is to identify different indicators to look at and how those indicators change with respect to a specific baseline that we are looking to compare as a result of a particular future development option or arrangement of infrastructure in upstream. So as you can see here, we have two groups of indicators. These have already been discussed in the previous presentation by Georg, but we have ecosystem services with respect to on-site effect, which means, for example, biomass production expected from a specific wetland, papyrus fiber production, or the level of live stock that the specific wetland is able to support, greenhouse and change in purification or waste treatment. Now, these indicators are identified as equations, as a simple linear equations were developed in order to help us compute a magnitude, or at least the relative magnitude for these indicators. The way they are done is we identified what's referred to as a vegetation units. These are basically class of land use types on the wetlands. We have open water, permanent swamps, reeds and grassland, woodlands, etc. So we have, after identifying these vegetation units and their corresponding areas, simple linear equations were developed in order to compute the magnitude of these indicators. For example, fish biomass production is computed as the summation of area of open water, permanent swamp, reeds multiplied by some constant, which gives us a kilogram per hectare of fish production from that particular wetland. Similarly, for papyrus, for example, is area of swamps times papyrus production kilogram per hectare. So these equations are coded into the Nile Basin decision support system. So whenever we run a scenario, it will give us the corresponding value for that of these indicators for that specific scenario. So the same is also true for greenhouse mitigation as well. Again, simple linear equations were developed in order to relate level of drainage of peatland versus the CO2 emission that is expected to occur from that particular wetland. So these are the first group of scenarios which are referred to as on-site effects, trying to model the impact that's going to occur on that wetland and impact on the corresponding wetland services that we expect from that particular wetland. So the other group of indicators refer to the downstream effect on hydrology, which means wetlands through their storage and through their storage of water, they're managed to change the flow regime to a certain extent. For example, they slow the flow, changing the peaks during floods, and these will have the potential to change the flow regime downstream, where wetlands are also able to buffer incoming flow through retention and have some impact on the water quality. So the change in the water in the wetland area will also imply change in these services of changing the flow regime downstream that the wetlands are going to produce, and therefore this will also be analyzed together in the Nile Basin DSS system. So without going into detail to demonstrate the implementation of this, is that we have this set of equations for indicators coded within the Nile Basin decision support system. So whenever the map that you see here is a screen capture of the model, it's a comprehensive model that incorporates all the irrigations and pretty much all the water in the current and future water infrastructures in the Nile Basin system, so driven by different hydrologic scenarios depending on the climate, on the anticipated future climate. So every time we run a certain configuration, we will be able to get the corresponding pattern of flow, both the magnitude and the duration. So that will be fed automatically into the scripts, and those scripts are able to do depth duration analysis in order to give us the corresponding change in the areas of those different components of the wetland that I talked about earlier. For example, change what percentage of the open area will change, or the permanent swamp of the reeds. So we will be getting those differential changes in the areas, and the scripts will further take those changes in areas and feed them through the equations that I showed in the previous slide for demonstration. And this will give us changes in those indicators, and those changes in indicators will be used to check or to analyze whether that specific scenario is viable or not under that comprehensive framework that also looks at all the other benefits that will be obtained from that particular development option in the future. So the takeaway point is the preliminary result. We have some results so far, and they are showing strong and complex implication of development option on the integrity of the wetland and ecosystem services. It's not as it's not a simple intuitive mechanism. Some small changes upstream could result major or a significant change in the ecosystem services downstream. So it's really a complex system, and the impacts, unless we have a really in-depth analysis, the impacts are not straightforward and intuitive. Therefore, I think the conclusion is future development plans in the Nile Basin should really incorporate and try to capture these complex dynamics between the ecosystem services and the particular future intervention in the future, trying to get a comprehensive view of impact of a particular intervention in the future. So having said that, I will come to the end of my presentation. Thank you very much. So if there are any questions, I'll be willing to take them later on. Back to you, Leonard.
Thank you so much, Dr. Yanis, for that insightful presentation. And from your takeaway message, it is a very critical issue in that some development somewhere upstream might have very huge impact on some of these ecosystems. So really, there is need to factor all these issues in development planning, so that at the end of the day, we have a development that is sustainable and a development that captures the connectedness and dynamics of this river basin and its ecosystems. Now, I will take this opportunity, of course, questions will come, but I will now take this opportunity to invite Lucy Iyango from the Ministry of Water and Environment, Government of Uganda, for his reacting presentation, or for his reacting speech. So Lucy, please, welcome.
Thank you very much. Can you hear me?
Yes, I can hear you loud and
clear. My apologies that I cannot use my video. It will require a lot of technical work, but I believe that I'll be able to pass on the message.
Okay, your voice is clear.
Thank you. Thank you to the host for this opportunity, and also thank you participants for taking an interest in this topic, and of course the presenters for excellent presentations. I'll start by saying water is the lifeblood of wetlands, and I believe that the three presentations have highlighted that. Then for all the presentations, we are presented with a number of tools that can be used to enhance wetland management. And also it is within the requirements of the Ramsar Convention and their guidelines to that effect to support that. What I would like, there are a few things that I would like to remark on. One, given that these are tools to be used at transboundary level, we need to look at how we domesticate some of these things, and also how we build up efforts that have been efforts within the region to that effect. Yes, the emphasis on monitoring of the resource is very key. And for me, I believe that all these tools answer to the wise use principle or for wetland management, we are looking definitely at the ecological character of the wetland and the trends in that ecological character. Now, if there are any changes in that ecological character, then there is a problem for us. So the tools that have been presented, the maps, the models, the inventory tool help us to do that. And of course, moving further, we need to also integrate this into the emerging issues, especially in as far as climate change is concerned. Now, when we look at the element of decision making and planning, this is very, very important. And for me, the challenge is taking it back to the Nile Basin initiative. How are we going to make these tools practical for our day-to-day use and not to remain at the Nile Basin Secretariat, for us to be able to share with the countries, for us also, for the Nile Basin to continually benchmark what is happening in the region. For example, when we look at the Wetland Atlas, Kenya spearheaded it within the region, and Uganda followed suit. Are we able to compare what the Nile Basin exercise has come up with in respect to the atlases that have been put? Two, in terms of management, we need to link the tools that have been proposed. I will give an example that, for example, Uganda in 1994 did a nationwide inventory, and it is that has marked the recipe for development in Uganda. And you'll find that all the national development plans refer to that inventory because it was an inventory that was done countrywide. It was an inventory that was ground truth. So we need to also bring down the satellite provided information to the ground to confirm that actually what we are saying exists for that matter. And arising out of that, we developed what we call the Kampala matrix. It is a matrix that assists in the management of wetlands. We were able to move forward through that inventory also and categorize wetlands into critical, valuable, and vanquished. Now, the other element where I want to comment is the modeling. The modeling is good, but the modeling must be integrated into policies. It must be integrated into strategies because it provides very, very good information in terms of the e-flows and other related trends. And the scenarios that you can get out of those, the decision support system is really very, very important. So we need to look at, for most of the countries, I'm very, very sure that their national wetland information systems or national environment information systems. How do we integrate what we have done from this study into those systems so that management of the resource is enhanced or is made better for posterity, still within the wise use principle? We must encourage that the ecological character is maintained. The issues of livelihood, we cannot run away from them. And as we look at the issues of livelihood, we need to also look at population pressure on this resource. How are we handling it? Development pressure, what is happening? Rapid land use changes, that's another one. How are we monitoring our resource to make sure that it is not becoming another land use given the pressures that are there? So there is a lot to benchmark from, there is a lot to learn from. And then, okay, yeah, we look at these inventories, we look at GIS and remote sensing. How about the capacity of the countries to be able to undertake these ones at national level? The cost of those high resolution satellite imagery, how are we bringing this on board, integrating this so that it is a practical intervention that will help the countries to move forward in their wetland management programs? I like the fact that we have mapped out clearly potential and hotspot areas, and we know their management status, but we need to also invest in the monitoring aspect. And for most of our countries, there's the element of also enforcement. How is this information being integrated into all these efforts? to ensure that we move forward. Then we are talking about transboundary resources. What systems and structures are we going to take advantage of within the regions, within the different countries, to enhance the integration of these tools into our day-to-day management? Which states or partner states require a bit of capacity? There's an issue of capacity that we need to think about. Which countries require additional capacity? When we look at information systems alone, it is specialized. What efforts are we putting in place to ensure that we have these specialized skills enhanced or developed within the countries, so that at the end of the day we have value for this intervention that we have put in place, and it becomes part of our day-to-day activities. And therefore, the other issue that I would bring on board is my sincere hope that it has been the consultants have also gone through training, capacity building at that level, so that these interventions continue. So those are some of my quick thoughts. And then these studies are very critical in this era when we are talking about natural capital accounting. We need to know our stocks, what is available, and how much can we use, how much is available for us for development, what is its contribution to national development, what are the policy interventions that we need to put in place, so that we are institutionalizing some of these interventions. Yeah. And still on that, Uganda and I think Rwanda has benefited from WAVE's project. And this is an opportunity for us to synergize. We talk about synergy, we talk about integration, we talk about nexuses. But I would challenge that we come up with practical takeaways, like the last presenter has talked about, that we follow through and we report about at the next meeting of the Nile Basin Development Program. But I cannot overemphasize the importance of inventories, the importance of decision support systems, the importance of national wetland information systems. It's an investment that is worthwhile, and I think we should invest in ensuring that we have them in place. I think for me, those are some of the issues that I want to bring up, and not forgetting, of course, the issue of water security. Wetlands are granaries for water. How are we going to use this information to convince the policymakers to put in place budgets for restoration of wetlands, for demarcation of wetlands? Yeah, so that we don't only have them on geo-reference, but we have them as practical policy interventions and also management interventions. I think I will end at that, and I will allow the opportunity for us to go to the next segment, which is discussions and questions. Thank you very much.
Thank you so much, Lucy, for your input. I think it's very clear. Let's do modeling, it's good. Let's generate this information, it is good. But then this information can only be enabled by policies, technologies, capacity, and of course, we have to ensure that this then becomes the culture at the country's level and at the organizational level for us to deliver on the sustainability of wetlands. I will now humbly request the presenters to open their camera so that we have animated question and answer sessions. And I will start. The first question will go to Jok. Jok, there's a question for you, and the question is saying that do your models accommodate the ability to factor the dynamics of the biodiversity, especially movement of populations of large animals? For instance, in the Sud, the cob, animal that is, it's known for this area. So how does your model capture these biodiversity issues, especially the large populations of animals with regards to movement, please? You're unmute. Joke, unmute.
All right, that's better. What we've looked at in our studies is basically what kind of habitats do different species need to develop well, to live well. The approach that we are taking, or that the different elements of our studies are building, is that we look into what is the change in hydrology, or in the flow that comes down the river. What effect does that have on change in flooded area, so the outline of flooding and the flooding depth and flooding duration? How does then vegetation react to that? So that means with the changes in flow and changes in flooding characteristics, there will be a change in vegetation that establishes. And this again has an effect on the biodiversity that again uses this vegetation. So any wildlife that feeds on this vegetation, be it fish, be it insects, be it mammals, if the conditions for them are getting less ideal, then we will have an impact. So it's this kind of cause, consequence, or impact chain that we are looking at, not the other way around. So we are not looking at a scenario where, for example, there would be a huge population of COP and would be grazing on these areas. So it's really the impact from the hydrological side that we are looking at.
Okay, thank you so much. And now to Dr. Jens. Of course, I see you have answered this question, but we will amplify it here. And of course, connect to the next question. How have stakeholders and experts provided input in validating these models shared? And then do the models cater for deliberate human disturbance of the wetlands? Yes.
Yeah, so the models basically depict any influence that the hydrology has on the wetlands in terms of inflows and precipitation and evapotranspiration change. And that means, as Johannes has also described it in his presentation, when we have any development option occurring in the upstream parts of the basin that influences the hydrology downstream, and the inflows to certain wetlands like the Sud, if outflows from Lake Victoria would change, then this would be depicted in the models in terms of changing water levels and changing inundation areas. So it is limited to that extent that if a particular drainage or a land use conversion within the wetland occurs, this is not depicted in the model. As Georg has said, so if, for instance, we have a large population of COP now grazing in the Sud, the changing vegetation patterns, this is not implemented in the models. Yeah, in terms of stakeholder knowledge implemented in the models, we had multiple workshops and stakeholder assessments under this project in Juba, in Nairobi, where we were all sitting on one table and we were discussing certain problems of certain wetlands in the Barakobo Sobat, in the Sud particularly, and all this information and also the concerns and needs of the stakeholders were considered and implemented. So it's a bit difficult to go into all the details that we were discussing back then, but it was yeah, it went into the directions like what are the wetlands used for, what are the benefits that local population has from the wetlands, and yeah, this was closely coordinated and under cooperation with all the countries involved.
Okay, and then now to Dr. Johannes. It was very insightful to hear your take-away message. For me, this gives the human face, the reality face to this modeling, complex modeling that we do. Now, with regards to options development and trade-offs, how is it ensured that the environment, the wetlands, will not lose when you are developing those options, when you're doing those trade-offs planning?
Okay, thank you, Leonard. I think this point, I would like to bring back one point mentioned by Georg earlier. I think on one aspect, yes, we would like to preserve the wetlands, but on the other side, there is the service, the economic aspect of it, the benefit that we're getting from the economic. So it's really a complex system or a complex analysis where we also need to bring in the stakeholders for them to really prioritize what is important for them. I think one of the challenges, for example, that there is for the wetlands is changing of the wetlands into agricultural land. Now again, it's up to the countries to decide, whether to 100% preserve the wetlands or convert part of it to agricultural land. So it's a complex system that requires the involvement of different stakeholders that would allow them to prioritize what's really important for them and what they really need to embark on. But again, the modeling framework that we implemented on the Nile DSS takes all this into consideration. It has the modeling side, which means for a specific intervention, it will give us the resulting impact, both its economic, from economic point of view, as well as from what will happen at the end of the day to the wetlands. And this is all brought back into what looks like a multi-criteria analysis that also involves the stakeholders. And final decision is left to the countries to select a particular trajectory of development options. Thank you very much, Leonard. Back to you.
Yeah, maybe if I can briefly add to that, just to give an example. We've done a study in the Mekong Basin, for example, where we were looking at hydropower dams. The Mekong is a river system where there's a lot of migratory fish. And so at the first sight, it looks like the hydropower dams, which were planned there, were bringing really a lot of economic benefits. But then when we were looking at it in detail, the issue was really that a lot of the migration pathways for fish would have been cut off there. That means while the hydropower dams would have generated a lot of economic benefit for a certain group of people, there would have been millions of people who are maybe catching fish with a value of $1 a day. Yeah, but it's 1 million people times $1 a day. And they would have lost all their fish catch. And it's not only this primary aspect of their livelihoods being cut off and their food source being cut off. But these people, in the study that we did, there was one scenario that these people would have moved into the cities, yeah, and would have caused again costs in those cities. So it's quite a number of things related to that, and so there are cost-consequence change that should be really looked at in detail.
Okay, yes, thank you so much for that response. And of course, the final question to Georg is that it was very interesting to note the hot spot analysis. And therefore the question is, did you factor in the increase of temperature and decrease of rainfall as a hotspot in the hotspot analysis?
We were looking into future scenarios, and yes, there we considered also climate change aspects.
Okay.
And also now, as this all feeds into the Nile DSS, any scenario can be modeled in the Nile DSS also with regards to different climate scenarios, and in that regard, changing runoffs.
Okay, thank you so much. I think we have lost Sadiki within, I don't see him online, but the wrap-up messages are clear from the reactions of Lucy and also from the response of the questions from the presenters. The wrap-up and the key messages are very clear. Now I take this opportunity to thank the presenters for your informative, insightful presentations. I also thank the ED for his opening remarks, and also for the TAC chair and other officials of NBI for joining us into this webinar. But most importantly, I want to thank the members of our audience, the people who are listening us from various parts of this globe. Thank you for joining this webinar. It has been a wonderful webinar hosting you and listening to all these messages, listening to all this information on issues of hydrology and wetlands in the Nile Basin. And without much ado, I beg to end this webinar here and wish you a good evening, good morning, wherever you are listening us from. Thank you so much, and bye-bye.
Thank you very much.
All right.
Bye.
Bye,
Thanks,
Leonard.
Leonard.
Bye, everybody.
Bye.
Bye, everybody. Cheers.